Okay, quantitative chemistry knowledge test. Now this is quite a small one, right? But there's kind of a lot of maths in it that you're going to need to do in class, right? So, quantitative chemistry. So first question is, what is the conservation of mass? That is where no atoms are lost or made during a chemical reaction. Okay, conservation of mass, so nothing changes. So what does it mean if the mass appears to increase in a reaction? So what I'm going to do is I'm going to draw a mass balance, right? And on that mass balance it's 7.02 grams. Then what I've got is I've got my beaker on the top, so the stuff that's in there weighs 7.02 grams. If the mass increases, that means one of the reactants is a gas. So that means it's gone in there, right? And it's made it heavier because the actual gas itself has joined in, right, with the reaction itself. What does it mean if the mass appears to decrease in a reaction, right? So there's my balance. Oh, it's much bigger balance this time. That was very well done. Well, that's 10.68 grams. That's right. But what happens this time when I've got my beaker there? Stuff must be coming out. So if stuff is coming out, that means one of the products is a gas, right? Because the gas is coming off. So it could be carbon dioxide, it could be oxygen, it could be hydrogen, whatever it may well be. Number 4, what are the 3 types of system? Draw a diagram showing the movement of energy and matter for each one. Okay, right, so I'm going to start off, I'm going to write open, I'm going to write down closed, and I'm going to write down isolated. Okay. Then what I'm going to do is I'm going to write down energy, and I'm going to write down energy, okay, because that's kind of what we're talking about. Then at the bottom, what I'm going to do is I'm going to write down matter, and I'm going to write down matter, and I'm going to write down matter. Then I am going to, in blue, I'm going to draw the actual system itself. Okay, now an open system is a bit like that. A closed system is like that, but it's kind of a bit like not everything can then be stopped. An isolated system is like that. Right, so if I go back to my energy, in an open system, energy can go in and it can go out. It doesn't matter where it does or what it does. Matter can also go in and it can go out. I've used a different colour there. In a closed system, what can happen is energy can go in and energy can go out, but matter can't go in and it can't get out. In an isolated system, energy can't get in and it can't get out, and matter can't get in and can't get out. So isolated means it's all the way on its own. Question number 5. What is the relative atomic mass? Okay, sorry, relative formula mass. That was a bit silly, right? It is the sum of the relative atomic masses, right? And often what we'll do is we'll do it as an AR. Example of that is very, very simple one is H2O, right? So the relative atomic mass of hydrogen is 1. Right, relative atomic mass of oxygen is 16. Then because there's 2 hydrogens, I do 2 times 1, so 2 add 16 equals 18. Okay, so that's the relative formula mass is 18 because that's the whole formula. Question number 6, what is the symbol for uncertainty? Symbol for uncertainty is a plus and a minus. Right, and how do you estimate it? What you do is you calculate the mean, you calculate the range, And the uncertainty, I'll do that in a different colour, the uncertainty, certainty, is half of the range. Question number 7, what is a mole? Right, I'll do it in black because obviously that's what everybody thinks. Right, it is where a substance contains the same number of particles, molecules, or ions. Okay, it could be atoms as well. How many particles are in a mole? There is, and this is a good number, 6.02 times 10 to the 23. And that is Avogadro's constant. Okay, so if there's 1 mole of me, there'll be 6.02 times 10 to the 23 of me, which would be awesome. Number 19, what is the limiting reactant? It is the reactant that is completely used up.